We're going to talk about patterns today. We're going to specifically talk about linear patterns. And when we talked about linear relationships, we talked about things where you consistently add or subtracted the same thing over and over again. For instance, if you worked a job and you made $12 an hour, well, after the first hour, you'd have $12. After the second hour, you'd add 12, be to 24. After the third, you'd add 12, be to 36. So a linear relationship is where you continually add or subtract the same thing over and over again, kind of like making $12 per hour, where you keep plus 12, plus 12, plus 12 for every hour. That being said, let's take a look at example 1. Joe's bowling scores follow a pattern. Write an expression that can be used to determine his score after bowling n times. Well, if we look at this, kind of like we were talking about there a moment ago, we continue to add the same thing over and over from term to term or from game to game of bowling. So plus 4 is a linear pattern. So the other thing to take a look at is these really represent ordered pairs, although you don't see that because 174, well, that was his first score. 178 was his second score. This is his third score and his fourth. So really, this is the ordered pair 1 in 174 and 2 in 178. And if you remember back in the day, we talked about writing equations, and we use the calculator to do that. So on this first example, I'm going to review that, although we're not going to depend on the calculator in this particular lesson. Let's take a look. For the x values, they go into list 1. So we're going to enter those in here quickly. And then in list 2 are the y values, which represent his bowling scores. And we get these guys all entered in here. And to use the calculator to do this, we'd hit, I'm going to hit second and quit. And then we're going to go to second data. And we're going to choose 2 variable statistics. Hit enter. And then we hit enter a couple more times. And we go down just like we did when we were writing equations aligned. We find the a and the b, which represents the slope and the y-intercept. So your equation here, if we're doing it in y equals mx plus b form, is y equals 4x plus 170. Now, it doesn't ask me to write an equation. It asks me to write an expression. Well, the expression is actually inside the equation. So I'm going to take this guy. Actually, let's clone it, and we'll slide her over here. What we're going to do to write the expression, quite simple. You just get rid of the y equals. So you have 4x plus 170. There's your expression. But then it says to write it so it's n times, or they're giving us the variable of n. So they don't want us to use the x. So we would just write it instead of with the x, with an n. So 4n plus 170. And this is an expression that represents that pattern. Now, we're not going to be dependent on the calculator, so where does this expression come from by looking at this pattern? Well, quite easily, you can see that the slope of that line was the pattern that developed of plus 4. So the slope represents the pattern, or the step, or the jump in the pattern. And then where does the 170 come from? Well, I don't see that here, but if you remember, in this equation, this is the y-intercept. That's what 170 represents. And the y-intercept is the place on the graph where it touches the y-axis, which means the x value is 0. So if these are my x values, the question is, what would the ordered pair be when x is 0? Well, what did I do? I went backwards by 1. I subtracted 1. So with my y values, or with this pattern, instead of adding 4, I'm going backwards. I would subtract 4, and I'd get 170. And oh, that's where this came from. The y-intercept is where the x value is 0. That being said, let's take a look at example 2 and see if we can use that without the calculator to determine the 27th term of the pattern. Just like we did on the previous problem, we're going to start by writing the expression. Well, the pattern that develops here, we are going to continue to minus 8 over and over again. Minus 8, minus 8, minus 8. so on and so forth. So to start my expression, well, that's the slope, or that's the number beside the variable. And in these, they typically like to use n, so we're gonna use n, so negative 8n. Then, to figure out the y-intercept, or the constant that we add to the n, or possibly subtract, I look at these as ordered pairs. This is the first, the second, the third, the fourth, the fifth, so on and so forth. But remember, to get the y-intercept, that is the place where it is 0. Well, I went backwards by 1. So I have to go backwards here. Well, in this direction, I was subtracting 8. So in this direction, I need to add 8. And that's going to give me 83. So the expression is going to be negative 8n plus 83. Well, that doesn't answer the question, because they want the 27th term. They don't want the expression that represents this pattern. Well, now that I have that, though, I can use it. I'm going to simply plug the 27 in for n. So it's negative 8 times 27 plus 83. And when I do that calculation, that's going to give me the 27th term in the pattern. So here we go. Let's check this out. Negative 8 times 27 and plus 83. So we get negative 133. That is the 27th term in the pattern, and that is the answer to the question. Now, if I asked you for the expression that represents the pattern, this would be your answer right there. All right, continuing. Number 3, determine the 50th term in the following pattern. Going to do the same kind of thing. Let's come up with, first of all, the expression. What's going on here? The pattern is going to be plus 10. Over and over, plus 10, plus 10, plus 10. So to start the expression, the slope is 10, so it's 10n. Plus or minus, well, what's the intercept going to be? Remember, this is our first, our second, and third, so on and so forth, ordered pair. But we want to know what the y-intercept would be. That's when the x is 0. So I went backwards by 1. I'm going to go backwards here by 10. When I subtract 10 off of 21, I get 11. So it's 10n plus 11. Well, to get the 50th term, we just plug that guy in. So 10 times n, which is 50, plus 11. Well, 10 times 50 is 500, plus 11 more. The answer here is going to be 511. So the answer to the question, the 50th term, is 511. We use this expression of 10n plus 11 to get that answer. Now, some of these you could probably do in your head somewhat quickly, but if I ask for like the 1000th term of a pattern, this expression is going to come in really handy. So keep in mind, we need to be able to write those expressions each time. All right, example 4. Tim scores the first 5 times he played video games are listed below. Tim's scores follow a pattern. Which expression can be used to determine his score after he played the video game n times? Well, the question is it a linear pattern? Well, we're working with linear patterns today, so most likely yes. But what we would do to figure that out is we would just go ahead and subtract. I'd take my second term of 45.99, subtract the 45.26, and we get, some extra buttons we press there. Let's try that again. 45.99 minus 45.26. Hit enter, and we get 73. So this is an increase here of 73. And if I plugged it in my calculator and subtracted those, yes, it would be plus 73 again. And lo and behold, all the way through, it's plus 73, plus 73, plus 73. So that means my expression is going to start with 73n. Well, this is the first, the second, the third term of my pattern. Well, to get the intercept at the end, I need the 0. I subtracted 1. So I'm going to go backwards here. Well, going backwards is going to be subtracting 73. So I take that first number of my pattern, 45.26. We subtract 73 to find out what our intercept is going to be. And we find out that that number is going to be 4453. So looking over your answers right now, we can see pretty quickly and easily when I add the 4453, the answer is going to be A. All right, on to the next ones here. Number 5, a little bit different, although very, very similar to what we've done. It says all points from which the following patterns would be contained on the given graph. Well, if this is a pattern, 1, -1, -4, -7, like we talked about earlier, this is the first number of the pattern. This is the second, the third, and the fourth. These are ordered pairs. So if these are ordered pairs, I should be able to plot them and go to 1, -1, which is right there. But oh, that doesn't fall on my line or my graph. So I already know that A is not going to work. Okay, so we're going to take a look at our next possible pattern. Once again, this is my first, my second, my third, so on and so forth. So this represents the ordered pair 1 and 5. Well, 1 and up 5. Ooh, that's right here. That's on my line. That's looking good. 2 and 8. If I go 2 and up 8, ooh, I'm off the graph, not 100% sure. Does it work? And if I keep going, 3 and 11 is going to be way off the graph. So let's go backwards. Okay, if I go backwards here by 1, that would give me 0. And since this is a +3, +3, +3 going this direction, I'd -3. So that should be the ordered pair 0 and 2. 0 and 2. Oh, yeah, that is my intercept. So most likely this is gonna have to be the answer. But just testing this out, if I looked at my other possibilities, 1 and 7. Well, 1 and up 7. Yeah, it's up here somewhere. Not going to be on the line. And 1 and 6. Likewise, 1 and up 4, 5, up 6. Once again, not going to quite be on that line. So your answer here for this one is going to be B. Those numbers are represented, or that pattern is represented by that graph. Taking a look at our last couple of examples here. Example 6 says the following diagram shows bowling pins set up in rows. If the pattern continues, how many pins would be set up in the 45th row? Write an expression in terms of n to solve. Well, here's row 1. And in row 1, I've got 1, 2, 3, I've got 6 pins. So really, that's the ordered pair of 1, 6. And in row 2, if we count those out, 3, 6, we got 9 pins. So that's really the ordered pair 2, 9. And so on and so forth. The next one here, this is really the ordered pair of 3 and 12. 12 pins in that row. So the pattern that develops from row to row, we went from 6 pins to 9 pins to 12 pins. I add 3 and I add 3. So to start my expression, it's going to be 3n. And then to get my intercept, remember that is when we are at 0. So 0, comma, what? Well, I went backwards here by 1. And this pattern here with the y's kept adding 3. So I go backwards here by 3. Well, 6 minus 3 is going to be 3. So my expression here is going to be 3n plus 3. So that answers the part of it where it says to rate the expression. And now I use that to solve by simply plugging in. I want the 45th term. So in for n, we put in 45. So 3 times 45 plus 3. And we go ahead and do that calculation. 3 times 45 plus 3. Enter. So the answer for this is going to be 138. So the 45th term of that pattern is 138. All right, taking a look at our final example here. It says, given the following pattern, determine the number of stars that would be in the 23rd group. Write an expression in terms of n to solve. All right, well, what's going on here? Here's my first group, my second group, my third group. In this group, there are 3 stars. In this group here, there are 8 stars, so that is an increase of 5. Well, the 8 stars now jumps up to, if we count those out, there are 13 stars. So that's another increase of plus 5. So my expression is going to be 5n. And then to figure out the intercept, remember we've got to go back to 0. So this is the first group. So go back to the 0, and I subtracted 1 here. So I'm going the other way. So instead of adding 5, I'm going to subtract 5. Well, off the 3 stars, I subtract 5 stars. I would have negative 2 stars, which isn't possible. But for the expression, that's what I need. So it's going to be 5n minus 2. All right, so we write the expression in terms of n to solve, and then it wants the 23rd term. So I'm going to plug in here 5 times n, or 5 times 23, minus 2. And we take 5 times 23, minus the 2, and we get the answer here of 113. So the 23rd group of stars would have 113 stars. So guys, these are all expressions, or all patterns that are linear, and it closely relates to the y equals mx plus b like we demonstrated in that first example. But hopefully you're not going to need a calculator for that. You can just figure out your slope or your number beside your variable by figuring out the pattern that develops, the plus 5 in this case, and then you figure out your number in the end by going backwards 1 to the 0, which is your y-intercept essentially, and you go backwards with your pattern. In this case, we had to subtract 5 off to get that number. Anyway, hope that makes sense, and if you've got questions, I'd be glad to talk to you. Let's see you in a Google Meet, and have a great week, and we'll see you another time.